مركز التعلم الذاتي، ريادتك للتعلم.
Okay, so today we'll be taking forecasting, inshallah. This chapter has some theory as well as some problem solving. We'll be taking a number of things. We'll take some basics with regards to forecasting, and then we'll be taking some models of forecasting as well. And also we'll be taking some models of how to measure the forecast accuracy as well. So what is really a forecast means? A forecast means a prediction. You predict the future. In Arabic it means, a tempo. Variable of interest. You cannot measure you make a forecast about something in the future without specifying exactly what will you be making forecast about. So for example, you want to make a forecast, then you need to find out what to make a forecast about. For example, a forecast about the weather, a forecast about the demand, a forecast about the number of students who will be enrolling in the university, for example, or the forecast about the students who will be majoring, for example, in operations management. So you need to specify a variable of interest, as well as you need to also provide a time statement. For example, for which year you're trying to make a forecast. Okay? Is it for the upcoming period in terms of next week, tomorrow, next year? So you need to have a period of time as well. We make forecast about such things as weather, demand, resource availability. So a number of things you could make a forecast about. I'm sure you have so many things in your mind that you do on a daily basis, on a weekly basis, that you intentionally or unintentionally you make a forecast about. Okay. Forecasts are an important element in making informed decisions. Of course, they are an important point. Let's take, for example, the forecast about the demand. Okay. Once you have a forecast about the demand, what you will benefit from that demand, for example. We know that in operations management, one of the things that we need to find out is to aim for is to match the supply with the demand, And therefore, if your forecast of the demand is accurate, then the supply that you will provide in terms of the capacity, in terms of your production, most likely will match with the demand, and therefore the level of waste or the level of understock will be much less, and you will most likely close to your target. Okay. The other thing is that a good forecast of the demand enables the company to make informed and important decisions about capacity planning. For example, if you are planning to introduce a product, and for that product you need to build a plant, okay, you need to find out how much most likely will be the demand for that new product. Therefore, a good demand forecast for that new product will enable you to build the right size of the plant, isn't it? So that you don't want to build a large plant and then you find out the demand of the product is going to be a small demand. Or you don't want to build a small one and then you find out that the demand of the product is huge. Therefore, you will find that the forecast of demand is connected to some crucial decisions, some big long-term decisions as well. And therefore, it is important that you spend a good amount of time in selecting the right model to make a good forecast, isn't it? You really need to have two things. Okay, you need to have the expected level of demand. By the way, we'll be focusing more onto the demand because it's of concern to us. It's a crucial variable, although we could forecast other things. But for example, when you talk about weather, it's not a business variable. It is more of a different type of variable. It's not the specialty of business. In business, most likely there will be more emphasis on demand, especially in operations management and marketing and such fields. Two important aspects of forecast. There is the expected level of demand and the accuracy. You have your actual data, for example. Okay, you have this actual data. Let's assume this is your actual data. Okay, when you make an expected level of demand, let's assume that will be your forecast. It will be more of a line through this one. Okay, so the expected level of demand, you are trying your best to make the expected level of demand as close as possible to the actual data. But of course, since you are talking about the future, most likely it will not be perfect all the time. Okay, therefore, it is important that you measure the deviation between your forecast and the actual data. Okay, for example, if your line is in here and your actual data in here, then you know that your expected level of demand and the actual demand, they are way different from each other. Therefore, based on this one, when we get an expected level of demand referring to your forecast, then it is also important that you also find the deviation between your forecast and your actual to tell how good you are, isn't it? Okay. Expected level of demand, we are referring, to the, recurrent, what we call it, recurrent, patterns in data. In data, when you look at the data, you will find some recurrent recurrent patterns in the data. That recurrent pattern in the data will be so much useful in making a forecast. For example, when you look at this one, okay, at this type of data, what do you see from this data? Mm-hmm. Upward trend, isn't it? So you're most likely, since there is a trend, most likely your forecast will have to follow this one, isn't it? But if your actual data is something like this one, of this pattern, what type of pattern in this one? There's what? There's like more of like a fluctuation, a type of fluctuation in there, going up and down. Okay, that could be like a seasonality or something, and therefore most likely your expected level of demand and your forecast will have to follow this pattern as well. That which we call it a structural variation. A structural variation is a variation in the demand that will keep on recurring all the time. It's like a pattern that will keep going on and on into that demand. When you look at this one, that trend, it wasn't only from this period to this period. It was there. It's a recurrent process. It keeps going up and up. And therefore in here as well, there is also a recurrent pattern in demand. It goes up and then down and then up, and most likely they keep on doing the same thing. What we call it a recurrent pattern of demand. That recurrent pattern of the demand or structural variation in demand, it is important to spot in your actual data. The more you spot from those ones, the more likely your forecast will be more accurate. Okay. There's also, of course, the accuracy that we have talked about, the potential size of your forecast error, which just simply means your deviation, the deviation from your expected level of demand or from your forecast, and the actual data. Okay, that you need also to measure. The closer you are to the actual data, the more the accurate you are. The farther you are from the actual data, the more the error. Okay, the deviation there from your your forecast to the actual data. Okay. Once we solve problems, things will be much clearer of course. There are some features common to all forecasts, and it is important to understand these features so that our expectations could be realistic ones. Okay. Techniques assume some underlying causal system that is existed in the past that will persist into the future. We're assuming that if there was like a trend, we're assuming that when we make a forecast for the future, most likely there will still be an upward trend, isn't it? So we're assuming some system that was there in the past that will still be in the future. If there was like a fluctuation or there's a seasonality or up and down in the past data, that seasonality will continue for the future. So what was in the past will continue as well into the future. If the past wasn't there in the future, or that assumption cannot be made, then it becomes really hard, to make a forecast. Forecasts are not perfect. Okay, that is something you also need to be aware of. Is that you cannot, obtain perfection into forecast. Okay, if you try to obtain perfection into a forecast, then most likely you could spend all your money trying to find a good forecasting model, and you will end up not finding anything. Therefore, there is no problem that there is deviation between some deviation between your forecast and your actual data, but that deviation shouldn't be large enough so that your forecast will not be realistic enough to make good decisions. Okay, some deviation is not a problem, and therefore, okay, forecasts, they have error, but that error will have to be a realistic error. Okay, and it has to be under control. Forecasts for groups of items are more accurate than the false for individual items. That is also another fact about forecast. For instance, if I want to make a forecast, okay, about your grades, like for the upcoming midterm, let's assume, okay, most likely it will be easier for me to give a forecast of your average, grade. Okay, most likely your class will be around this much because I've already taught this course several times in the past. So most likely I can tell, for example, how much will be around the average. Okay, the average of the midterm. But it is hard so much for me to tell exactly how much will be the grade for each one of you. How much will it be? Okay, that's not easy. Okay, you could tell the average how much, but the individual score of each one of you, it will be hard. That's exactly the same statement in here. Forecast for the group of students, like something like an average, it's easier to, and more accurate compared to the making a forecast for each and every student, how much will be their grade into the exam. Forecast accuracy decreases as the forecasting horizon increases, and that's also true as well. Making a forecast about tomorrow most likely will be more accurate compared to making a forecast about, the same day after 1 year, or after 1 month, okay, or after half a year, okay, because most likely the tomorrow you at least have some information maybe today about your customers, but for the next year your level of knowledge is less, much less compared to tomorrow, okay. We have talked about forecast accuracy. Let's pinpoint to this one further. Forecasters want to minimize forecast errors. Okay, as a forecaster, of course, you want to minimize the error, but it's nearly impossible to correctly forecast real-world variable values on a regular basis. You could do it once or twice or sometimes, but all the time you have perfect forecast. Your forecast is equal to the actual demand. That most likely not possible in the reality. So it is important to provide an indication of the extent to which the forecast might deviate from the value of the variable that actually occurs. So based on this logic that you cannot obtain a perfect forecast, therefore it is important that you keep a record of the deviation between your forecast and the actual demand on a regular basis, so that you tell, for example, if maybe you could tolerate some level of error, but if your error went up, or it has increased over time, then maybe it is time to change your model to a different model that will give you a better prediction. Okay. Forecast accuracy should be an important forecasting technique selection criteria, of course. Okay, minimizing the error that could give you a good indication of the best model. Therefore, when you select between model, you should select that model that will give you the lowest error. Okay, so lower error means higher accuracy, isn't it? If errors fall beyond acceptable bounds, corrective action may be necessary. That is important. If your forecast will deviate after some time beyond some limits, then maybe it is time to change your forecasting model to a one that is better fits to your data. This could be because there was a change into your customers, the behavior of your customers. They have changed their behavior from one of your product to another maybe type of product, or maybe if it's about the students, maybe they're new students, they come in who they have different behaviors, who they got mixed with past students, and they have introduced a different pattern into the data, and your previous model now it's not as suitable as the previous model. Therefore, maybe you need to change your model. So there could be different reasons, but then you will need to find out what's the best model for your data so that you make a good forecast. Is that all clear? Okay. In that respect, we have a number of forecast accuracy matrices, okay, or forecast error measurements. We have something called MAD, MSE, and MAPI. Okay, mean absolute deviation, mean square error, and mean absolute percent error. We're going to take an example on this one. Here's the example. But before we get the example, we need to find out the differences between those ones, because we'll not be taking those ones afterwards after taking the problem. So just let's shed some light over the differences between the two, between those three. Let's take some simple example. Let's assume this is your actual and this is your forecast. Okay. Okay, let's find out, the error. What's the difference between the forecast, the actual, and the forecast? Let's find out this one. Error. How much the error of the first one? 2. Minus 2. Minus 3. 3.
How much is the total? 0. The total is 0. Okay. What do you see in here? Do you think the error was actually 0? Was it 0 at any point in here? No, it wasn't 0. Although the total is 0, but in fact the error wasn't 0. It was like 2, and 2 is an error. Minus 2 is an error. So there was always some error. But the total of these ones is like, the 0, which is not a realistic measure in this respect. Now, although, the normal deviation could be one measure, but, it could create, a problem in here. You could actually have a 0 error, but in fact your error is not actually 0, it is some value. Now, how can you what do you think the problem is originated from? Because of what? This problem has occurred because of what? Because really of the minus, isn't it? The minus cancels with the positive, okay? So if in that respect, then how can we get rid of the minus? To get rid of the problem of the minus. One way is to use what? The absolute value. The absolute value will get rid of the minus. What's the other way? How can we get rid of the minus? Multiplying by minus is like taking the absolute. It's the same way. You take the square. The square of the variable of a number will eliminate also the minus. That's exactly what's in here. Mean absolute deviation is mean absolute. The first way of getting rid of the minus, taking the absolute, and the other way, mean square deviation, square error, is the other way to get rid of the minus, the square. So one way is to use the absolute, and the other way is to take the square. What's left is the mapping. Okay, take a look at this other example. Mean absolute percent, mean absolute. So the word absolute is like the mean absolute mutlaq. Mean absolute percent error, but the difference in here is that we take the percent. As you can see, we take the actual minus the forecast, and we divide the difference by the actual. So it's like a percentage when multiplied by 100. Look at this example. It will illustrate the point. Let's assume that you have, the actual is 100, and your error was, 2. Okay. And let's assume in another one, your actual is 1,000. And your error was, again, 2. Is the value of that error is the same as the value of that error? 2. Hmm? As an absolute value, as a normal value, it is the same. But in correspondence to this one, the 2 compared to the 100 is more significant compared to the 2 compared to the 10,000 to the 1,000. Let me give you another example. 10 and 2. Now look at this one. The 2 has more significance when compared to the 10, as compared when the 2 to the 1,000 and the 2 to the 100. Then based on this one, okay, if you only look at the, you focus onto the error itself, then your statement might not be accurate. You might think, that this is, the error is small, but in fact it is large. Or you might think that the error is actually large, but it is small. And therefore, to get rid of this problem and to get, a more accurate, measurement over this one is to divide what? To divide the error by the actual. If you divide 2 over 100, it will give you a statement in relation to the 100. Okay, how much is 2 over 100? Multiplied by 100%? 0.02. So that's 2%, isn't it? 2%. 2 over 1,000? So point, is it 0.2?
0, 0.
Okay, 0.02. So is it like 0.02%? Calculate.
After 1 to 0.
We're putting the number into percentage. This is percent. We're multiplying by 100% in here. 0.2%. That's 0.2%, and this one is 20%. Okay. So although they are all 2, but now when we divide it by the actual, we have different numbers. We have 2%, we have 0.2%, isn't it? 0.2%, and we have 20%. Now they are different from each other. Okay. So that's exactly the mapping. Mean absolute percent error. If you have this type of data in your actual data, this type of data where there's like, between one data and another, there's a change into the scale of the data, then map is a good one because it will get you, the exact proportion of error compared to the actual data. Mean absolute deviation gets rid of the minus. but it doesn't change really too much in the data because it doesn't amplify the data. It's just normal, you just take the absolute. But the mean square error, no. It gets rid of the minus, but it also magnifies the data because when you take the square, okay, a small error like 2, it will multiply it by 2, isn't it? It will take the square of it. I mean, it will take the square of it. It will become like 4. So the error will actually be multiplied as if you are putting the under a microscope and you are making like, you know, the error larger and larger, which is good in some type of data in which you are talking about some critical data, you know, where the difference, although it is small, but the cost of it is so much high. For example, you are talking about the differences between, you know, actual blood requirements and maybe your forecast. Okay, although the difference could be, for example, sometimes small, but the difference is huge because it affects the lives of the people. So you want to make sure that you know your forecast of blood is accurate. And also, for example, the gold, or maybe, you know, some other type of data in which a small deviation, it has so much cost. Okay, therefore, amplifying the error would give you a better picture. Okay, so although they are all measurement of errors, and you only need to select one of them for your data. But in fact, each one of those ones might have different behaviors with respect to the data. Good. Now let's solve this one. Let's solve this problem. Get it. Find first, you know, the difference, the actual minus the. In this problem, we're going to be finding the MAD, the MSE, and the MAPI. Okay. Okay. 3 problems in one using the same data set. So let's find out the difference first. Minus a 3, 4, 3, minus 2, 1. Okay. The absolute of this one. The absolute 3, 4, 3, 2, and 1. What's the total of this one? 13, 1, 3. 13. Okay. We can find out, you know, the MAD according to the previous, you know, MAD equals to. It's minus 1 and becomes 1. Okay. 108 minus 109, it's minus 1, and the absolute of it is 1. اكسب معي شباب. Okay, so the total of the actual minus the forecast according to this one, the total, you see this summation here, it refers to the total. Okay, so after taking the difference and the absolute difference, then you add up and they get the total, which is 13. You divide it by n. So 13 divided by n, by how much is the n? 5. That equals to 2.6. 2.6. Okay. Remember, n in here, okay, refers to the pairs in which you have taken differences between all of them. Okay. In here, for example, you have taken differences between 5 of them. Okay. The number of pairs at the numerator. Okay. For example, if you found 5 differences, then you will divide by 5. But for example, let's take this. Let's assume the actual of the 5th period is not there. There was no actual in here. Okay. There was, let's assume there was some, you know, or there was like an actual, but there was no forecast, let's assume. Okay. And you only have a data where you have forecast for 4 periods. You will have how many differences in there? You will have 4 differences. How much will you divide by? Will you divide by 5 or divide by 4? You will divide by 4, because although you have 5 points, but only you have 4 valid points which you can find an error for. Therefore, you divide by the number of deviations at the numerator. Okay. So MAD in here is equal to 2.6. Now let's find the square error. Okay. That's 9, 16, 9, 4, 1. And the total of this one? 39. 39. Okay. MSE equals to let's just remove this one. There's no need for it again. What's the formula for it? divided by n minus 1. In some of the books, it's divided by n minus 1, although it's an average, it's a mean. Usually we divide by n, but in this book we have n minus 1, so we'll have to abide by this formula. Okay. 39 divided by 5 minus 1, which is 4. That would give us how much? 9.75? 9.75. Okay. Now we can find, the percent error. Okay. The absolute error, we already have it, which is this one. We only now need to divide by the actual. Okay. So where is the actual? Here's the actual, 107. So this one, the first one will be 3 over 107 multiplied by 100, isn't it? See? 3, which is the absolute, divided by the actual. You multiply by 100. That will give you some value. What is that value? 2.8. 2.8. The other one is which? 4 divided by, multiplied by 100. 3.2. Then we have 3 over 115 multiplied by 100. That equals 2.64. 2.61. This one is 2 divided by 118 multiplied by 100. That equals to 1.69. And the last one is 1 over 108 multiplied by 100. That gives us 0. 593. 0.93. Okay. And the total of these ones? 11.23. Okay. So MAPI simply, it is the total again divided by the total, which is this one, divided by n. Okay. MAPI is equal to 80 minus FT absolute summation. This one is divided by 80 multiplied by 100. The total of this one, that's divided by n. Okay. So this whole thing, we have it how much? 11.23. The numerator divided by n, which is 5. That will give us how much? 2.255. Okay. So you can see, the different, but this one is like, because it is all percentage. You see these numbers are all percentage because we have multiplied by 100. Okay. Therefore, this one most likely is a percentage. Okay. It is an average of percentage, therefore it is a percentage, 2.255%. But it's an error as well, a mean error. You can see how the MSE is the largest of them. Not because the error is, it's high in and of itself. It is the same as those ones, but it is high because it is a squared one. Okay, so as I told you, if you have this type of data, maybe this will tell you that the difference is a critical one. You can see the magnification. You are allowed only to use one error. Okay, when you solve a problem, there is no need to use multiple errors, and you are not supposed to compare between the errors which one to use. Okay, or in terms of like you take the lowest out of them. Okay, it's not you are comparing. You are supposed to compare between different forecasting methods, not because of different accuracy measurement, different forecast accuracy measurement like MAD. You compare between MAD and MSE or MAD and mean absolute deviation. You only select one of them. It's all right. Okay. So do you have any question from this one? Is that clear? Okay, we need to solve more problems, of course, but that will be later on, not today. Forecasting approaches. Now we'll be talking about the different, models. Generally, at the outest, we have two approaches. We have the qualitative approach and we have the quantitative approach. We'll be focusing more into the quantitative part, but we'll have, an overlook at the, on the qualitative part. Qualitative forecast, qualitative techniques permit the inclusion of soft information such as human factors, personal opinions, hunches. These factors are difficult or impossible to quantify. Although in the qualitative forecast, the end or the product of the forecast is that you need to give, maybe if you are to give a number, then you need to give a number. But the methodology that you will be using to get that number, it will have so many different things. Like, it could have like an opinion, it has like feelings, it has, the level of experience of the person, which, sometimes you cannot copy this type of method that one person used to another person. That's the only problem, with the qualitative forecast. It is hard, to use the same like a quantitative one. It is in which there is one model which you can use by different people and they will give you the same exact forecast. So, but despite that one qualitative forecast, the good thing about it is that you can include several variables. You could have a quantitative plus a qualitative ones. But in the quantitative modeling, you can only include, type of hard data, only in terms of like numbers. Other than numbers, like the feeling of the people. For example, you have developed a model, okay, and the model is telling you that the demand most likely for tomorrow will be around 20. But you have a feeling because of some, weather conditions and other things that, there could be, that demand could be higher. It could be, for example, because of like, the temperature would go, for example, up or something, let's say. So maybe you are feeling that the demand could be higher than the 20. Okay, maybe that one cannot be input directly into a quantitative model. Although there are some other models which you can use, but generally, not all of the qualitative variables can be input into a quantitative one. Quantitative forecasting, quantitative techniques involve either the projection of historical data or the development of associative methods that attempt to use causal variables to make a forecast. These techniques rely on hard data, while the other ones, they focus more into the type of soft data. This one is on hard data. Hard data means like numbers, chooses numbers. Actually, in the quantitative forecasting, we have two models, okay, or two approaches within this one. We have the historical, using the historical data pattern, and we have the associative models. The associative methods are pretty different from the word associate, okay, and the historical ones are pretty different. In this course, we'll be focusing more onto the historical ones, what we call it the time series. Okay, what is the association ones? We have taken already, regression. Have you taken regression in stat? Regression analysis, or the linear equation, which is associative models. You remember this equation, y equals to a plus b 1x1 plus b2 x2. This one is a type of an associative model. What does it mean simply? Although we're trying to make a forecast for y, what will be the next value of y for the future, let's say tomorrow. To find out the value of y, according to the model, the value of y depends on the values of x1 and x2. Then it means that, x1 and x2 are associated with the y. Okay, the value of y is associated with x1 and x2. Example for this one, there are several examples and the useful ones. For example, you remember the example about the temperature, okay, the ice cream, okay. Maybe some companies they associate the level of ice cream consumption with the level of temperature. When the temperature goes up, the level of ice cream consumption goes up. So that could be like an association variable. Some other companies, what they do, for example, they found that actually the demand for their product depends on the level of advertising that is broadcasted in a TV. The more you give more advertisement in a TV, most likely your demand will go up because there's an association between them. You can see this one in several channels, TV channels. There are some companies which they have some repetitive ads, okay, every day. So the more you put ads, the more most likely your demand will go up. Okay, so they believe that there's an association between the two. So you can, if for example, if you spend 20,000 Oman Riyal on ads, this will be most likely your demand. Okay, if you spend 30,000 Riyal Omani on advertisement, this will be the level of demand. There's an association between the two variables. You can find several examples in reality in which you can associate between one variable and another one. We have taken this one in statistics, in fact, an association between variables. You remember, the R square, adjusted R square, when you associate between different variables. If R square goes up, then it means that, X and Y, there's some relationship. Over 90%, there is higher relationship between the two. If it is lower, then the association between the two is low. There are other models which we'll be focusing on in a second, which are called the time series models, which basically they do not depend on other variables, but they depend on themselves. A Y depends on the previous Y. It doesn't depend on X. But we'll talk about this in a second. Let's just finish the qualitative forecast, and then we'll be talking about the time series modeling, okay, if we have the time. In the qualitative forecast, generally we have a number of models. Some of these ones, executive opinions, sales force opinions, consumer surveys, and Delphi method. Let's just scan over those ones. The executive opinions, a small group of upper level managers may meet and collectively develop a forecast. An example of this one, like for example, operations manager with the finance, marketing, accounting, and all of those ones, they sit together with top management and they try to brainstorm and they try to develop a forecast of the future. So the development of the forecast of the future uses here executive opinions, like operations, chief executive officer of operations, chief executive officer of the finance, and all of those ones together, and they develop a forecast. You could have also the sales force opinions. Sales force are, the people who they are associated or they know more about, some customers, because salespeople, they're always in touch with the customers. That's why they're called salespeople. They are in direct touch with the customers. So the point behind this one is that salespeople, they understand their customers better than other people in the company because they interact with the customers, so they have better experience. Therefore, if you are trying to make a forecast about the future demand of those customers, then who would you ask? You would ask the salespeople. They have better experience. And also another example, that if salespeople are assigned to different parts of, let's say, in Oman, for example, you have one salesperson into Al-Batana, another one into Al-Dakhli, another one into Al-Sharqi, another one in Dhufar. So you could ask each one of those ones, what do you think about, the region that you are assigned to, their customers? Do you think they will buy more of our products in the next year? So they can give you an indication about, the level of demand for the next year. But there's a problem with the salespeople as well, that, is that they could give you, purposefully they could, give you not an exact or an accurate, an incorrect forecast, okay? Because if, for example, a promotion is attached to the level of demand, then they might give you a wrong number in order to get some bonus or something because of that one. So that needs to be, be careful about when you depend on salespeople. Consumer surveys is another way. We know about the consumer survey. Companies, they have this one. They send surveys, or sometimes they call customers and they ask them a number of questions to understand, their satisfaction with the product. If they are highly satisfied with the products and the different services, then most likely they will keep coming back and again and again. So most likely the level of demand would go up. But if the overall, response from the customers is, it's not that much high, then maybe your expectations will be moderate or low with regards to the customer, with regards to your demand. Also another method, which is the Delphi method, which could be, a more structured one in terms of qualitative forecast. An iterative process intended to achieve a consensus forecast, like Zumai. An iterative process intended to achieve a consensus forecast. How does it work? You have like a number of, experts in different areas, okay? Most likely these experts are not in touch with each other, but they are all, they have the same, they are expert into the same area that you are trying to make a forecast for. That variable that you want to make a forecast for, they're all expert into that area, but they are not in touch with each other. So what do? You develop a questionnaire. You send it to those experts, expert A and B and C, okay? They fill the questionnaire and they return it back to you. You look at their answers. You see their answers, but they do not see their responses, who has, each one responded. So you look at the answers, you summarize the responses, all of them, then you send them again the questionnaire with the responses. You change the questionnaire based on the responses. For example, if they're like open-ended questions, now maybe you want to have some, options in there of the responses in there. You send it back, but you don't write the names, most likely, of the people who they have said this response and this response. You send it back to them again. It's an iterative process. You send it back to them. Now, for example, if I am one of those ones, when I read the responses, okay, I don't know who said this one, but when I see the response, maybe in that response there's some piece of information that I have missed in my previous response. That piece of information, that's right. So I'll change my forecast based on this one. I'll adjust it, I'll refine tune it. So based on this process, you go back and forth, maybe let's say a number of iterations, 5, 6 iterations, then you could obtain an accurate forecast. At some point in time, they will try to converge into some more accurate number. But at the same time, you have used an expert opinion, but at the same level, you have tried to minimize the level of error into it. Okay, that's called a Delphi method. But the issue with the Delphi method is that you need to control the number of iterations. If you have so many iterations, maybe people can get bored. Okay, they might be responding to questionnaires. People, they might respond once to your questionnaire, but next time they might respond. So the number of people who they responded in the first time might be less, and the second time might be less than the first time, and the third time they might be less than the second time. So that could be an issue. Okay, that's with the qualitative approaches. Time series models. I've told you, there's associative models of quantitative models. And there are the historical ones, what we call them time series modeling. We will not be taking the associative models in this class. We'll be taking only the time series models or time series forecast. Forecast that project patterns identified in recent time series observations. Time series, a time-ordered sequence of observations taken at regular time intervals. Assume that future values of the time series can be estimated from past values of the time series. A point in the time series modeling is that we believe that all the information that you need to make a forecast of the future is actually there in your historical data. Then based on this assumption, based on this idea, is that then the more the historical data that you have, the more the knowledge that you have about your patterns or your future demand. Okay, let's take for example one example that will illustrate the point. Take this example. This is your actual. Okay. What do you think would happen afterwards? Do you have sufficient information to conclude 100% most likely it will go up? No. You don't have sufficient information. You know that it went up once, but you don't know whether it's going to go up again. Okay. Now let me give you more data. What do you think now? You have better knowledge, okay? Your knowledge of historical data is better. You know that this up and down has been repetitive more than one time. So most likely now, based on this one, it will go up again, okay? So this one is called knowledge of the amount of knowledge that you have from the past. It will tell you how much most likely your prediction for the future. The more the historical data that you have from the past, the more accurate will be your forecast for the future, okay? Which is in this respect different from the associative models, which depend on a different variable. Now this one, we're not making use of any other variable. It's the same value, it's y. The historical values of only y without any x in here. From y, from the past y, we'll learn about the future of y. You got the point? Future values of demand, past values of demand, we know about the future values of demand. Okay, so today we'll be stopping at this level, okay, and we'll continue next time, inshallah.